Hi, this is Nancy Baker, and this is a little bit of a presentation on the Abstract Sifter that will support this particular presentation that I made at ACS, or I'm going to make at ACS, and it's a fresh take on Excel for the synth meeting fresh takes and the super genius. Okay, so let me go over to Excel. And I'm in the Abstract Sifter. This is a version 9 of the Abstract Sifter. You can download it from my website, www.parleychem.com, and you may have to put a home after the com. I'm not sure. This is the new website. So here I am on a sheet that's called the curated list sheet. Here I'm illustrating that a lot of people who work with chemistry information have a list of chemicals and some sort of a number. Let's say I'm just pretending that I've done some sort of assay and I've got these numbers. They are totally made up. This list is made up. But I'm going to show you because you may have some actual chemicals you want information on. You can follow me and you should be able to help yourself get that information. So the first thing you have to do before you can get chemical information from the outside databases such as PubChem or the EPA's database, you have to get the identifiers for those chemicals. So I'm going to select where I want the identifier to go. That's the output of my function. And then I'm going to select the function. On the Abstract Sifter, you click on the AS Custom button. It used to be called EPA Custom. Now it's AS for Abstract Sifter Custom. And what I want to do now is I want to get the DTS XID and I'm going to select with chemical name or CAS. My function needs an input, and that's going to be the name here. So it's already pointing to column B. That's what I want. So what happens now is that for each one of these rows, the Abstract Sifter puts together a query, sends that query to the EPA's DSS Talks database APIs, and brings back the DTS XID. They are hyperlinked to the dashboard, and you can get quickly to a whole bunch of information there. The next thing that I do on the presentation is that I start bringing other information back. So let's take a look at what I can bring back. The EPA tabs up here on this custom ribbon. Preferred name doesn't have any other things under it, but here you can look and see that I have functions that bring back all of these chemical attributes, the Kinchy key, CAS, EUPAC, etc. So let's go ahead and try to pull one of those back. Again, you select the, you select the out. Okay, there we go. What was that about? Okay, you select the output. I don't need to do all of these right now. And I'm going to go get, say, the CAS. And I point to the DSS Talks ID. DTS XID is the short form for that. And I'm going to go out and get the CAS. Okay, we've got the CAS, and now I put a heading there for CAS, and the next thing I'm going to get is going to be smiles. And I'm going to get standard smiles, so I'm going to put smiles here. And then go ahead and get the smiles. I'm not going to take up your time by doing all of them. Again, the function requires an input. The input is the DTS XID. And now my smiles are back. And the last thing I'm going to go get is, let's do some PubChem information. I can get patent counts. Those take a long time though. So I'm going to get vendor. No, that takes a while too. I'll just do something quick. EC number from PubChem. Okay, we have to, if you want to get PubChem, we got to get the CID first. So I'm going to do the pub. Okay, here we go. So I can get the CID, that's their identifier, using CAS. How about that? And we'll point to column D because that's where I've got the CAS. Okay, so my CIDs are back, and now I'm going to go after vendor counts, which is something that is in PubChem. So vendor counts, and you have to have CID as the input to the function. So CIDs are in, F. This is kind of slow, so I'm going to pause the video. And now we had vendor counts. The CID is hyperlinked, so you can go to PubChem to look at it and check the numbers if you want to. One of the things that I really love about the way the Abstract Sifter works with chemical information is getting the structure diagrams. There are two ways to do that. I'm going to go ahead and insert column here. You can go out and put them in line. That looks like this. I'm going to just do these here. So I select the output rows, click on structure over here on get structure diagrams. What column contains the DTSX ID? That's A. And now we have the structure for these chemicals in line here in the Abstract Sifter sheet. There's another way to do that though, and I'm going to show you that now. But I'm going to pause the video so I can do some preparation. All right, a nice way to do structure diagrams is tiling. I'm going to show you how to do a fancy one right now. So I've made a label over here, which is the name of the chemical and its result score. And again, I just made these up. And I also colorized them using the conditional colorization. So I'll show you how this works. It's really simple. You just select the rows you're interested in, click on tiles, and then fill in these blanks here. So the DTSX ID, very important. What column is that in? The name is in column B. Colorize with column C, and you'll see why that's kind of fun. And then I've done a special label. I put it in column H. And then click OK. And the Abstract Sifter is going to create a new sheet called tiles, and it's going to take each one of these chemicals and put its chemical diagram on that sheet. And we'll have a tag here, or you can see here it is. And you can also then select the labels, and I'm going to make them bold, let's say. Okay. So what you have here is all of those chemicals on that sheet that I showed you I was working on with their scores or their results value, something I just made up. And then I have them ordered by that results value, and I also have it heat mapped. So the color of the frame around the chemical diagram reflects the heat map that you see on this page. So if this is a good colorization scheme, you have lots of information here in the tile sheet. You have the chemicals ordered by their scores or by whatever the results number is. You've got the diagram to look at. So if you're interested in picking out some structural elements that seem to trend with your results scores, you can do that. And then you also have the colorization around the diagram to show you the different breaking points in your sorted list of chemicals. That way, I really like that, and I think you'll enjoy doing that too. Okay, now I'm going to pause, and I'm going to come back and go on to the next feature that I showed you on PowerPoint slides. Be right back. Okay, I'm going to work some more on this list. My next question is, I have all these chemicals, maybe I tested or something like that, or found active in an assay. And I'm interested in knowing, what are these chemicals used for? I have some information about their structure and whatever assay I did, but I want to know what they're used for out in the real world. There's several ways in Abstract Sifter version 9 to do this. You can, first of all, the EPA has some information on chemical use that you can get in line. So I'm going to go over here to AMOS, synonyms, similars, and AMOS, and get AMOS chemical functional use. Again, function requires the DTSX ID. And what comes back here are the chemical uses that are in the AMOS application, which is an EPA online analytical methods and open spectra application. And then you can do that for as many as you want inline. Okay, I had a little problem with this Abstract Sifter on the cloud, so I've got it now on my local drive, which often works a lot better. All right, so what I'm going to show you now is more about chemical use. I brought back these strings of chemical uses, and I'm going to show you where I got those. This is the EPA website that I got those from. And we're going to now play with some of the other data on that website. So these uses are helpful and great, but what if I don't want to read them like this? What if I want a matrix format? The great thing about Excel is that matrices are so natural to Excel. So I'm going to show you how I can look at the use in matrix format. All right, so as usual, I'm going to copy a bunch of stuff here. I'm going to just copy these top ones. And I'm going to go over to what's called the EPA use matrix. And I'm going to paste. Okay, there they are. I'm going to paste my chemicals in there, and of course I have to have the DTS XID. Now I can go, when I select a row, and I'm just selecting one column in a row, and then I'm going to go over to this button called Get Use for Chems. And this button realizes that I'm on the EPA use matrix sheet, and it goes out and gets the uses that are on that website that I was showing you. I know these are really hard to read. Maybe I can make them a little bit bigger. And we can take a look at what some of these are. Okay, so some of these uses are additives, anti-infective agents, antimicrobials, biocides, drugs, enzyme inhibitors, so on. Now it's too big. Okay, and I'm going to go ahead and just get the uses for all of these chemicals that I brought over. So I just select the row I'm interested in and click on this button, and it goes out, does API calls to that website I gave you the URL for, and we're going to go to that website here and look at something right as soon as this is done. So it fills out the matrix, and this is kind of cool because it's a matrix. And if you have, say, 1,000 chemicals, it could be very difficult to read the results for one chemical. So there are several ways to sort it. Let's take oxalinic acid, and we're going to sort by this selected chemical. What that does is it sorts these columns by oxalinic acid so that all of the ones saying this chemical does have this use, all of these ones are here. There's a whole document to read about how these uses are put together, where they come from, how are they curated, etc. To be able to look at more information about this, so if you click here, you go to the DS, well, let's just do both of it. Let's click here and go to oxalinic acid at the EPA's website, the CompTox Chemicals dashboard. And there's information oxalinic acid, and you have all sorts of subheadings here you can look at. But if you click on this link, you go to this AMOS application website. And this gives you analytical methods and all sorts of different documents that are not really in the PubMed literature. Some are, but most of them are not in the PubMed literature that have to do with this chemical. And what I wanted to show you is this sub-tab here, functional uses. These are the uses that get pulled into the Abstract Sifter EPA use matrix. Okay, so this matrix format, I'm going to show you some more examples of that in just a minute. The EPA has one way of getting chemical use, but the literature has another way. So I'm going to show you that using mesh terms and mesh pharmaceutical actions. So we're going to select these chemical names, and we're going to go to another sheet, which you may have to unhide, called the mesh use matrix. And here you put the chemical name here, and I don't want to do that. Let's do it without the. It's just the chemical name. And we have to go out and get the mesh UID for those chemical names. And that's over here under PubMed Mesh. Get Mesh UID, and like every other function, it has to have an input. Oops, no, I selected the wrong input function, or input to the function. Okay, so B is the input. We want the output on A. So this is going to go do a search in Mesh for these terms, and not all of these chemicals may be in Mesh, or we may have to go manually and look up, like this one right here is not. Some of these things are just not, and you could go out and look for them and find a different way to, like if you took off this, no. So I would just normally go to Mesh and look these up, and you might have better luck. And I'm just going to, for now, so I don't bore you, I'm going to just take that out of there. So all of these chemicals are in Mesh, and they might have uses associate them with them. In the case of Mesh, this is either like specialty use or pharmaceutical action. So we're going to get some different kind of information from what we got from the DSS talks, or from the AMOS database. But I'm going to use the same button, which just happens to know I'm on the Mesh Use Matrix sheet, and it's going to go get the uses, if there are any, for these mesh terms. Okay, so not a lot of them have uses, but let's go ahead and let's click on rifampicin and sort by it and see what it's got. So rifampicin is a cytochrome P450 CYP2B6 inducer, nucleic acid synthesis inhibitor, 2C8 inducer, and so on and so forth, and leprostatic agent, and some other things. And you can oxalic acid, topoisomerase inhibitor as well. So you can get a different viewpoint of what the use of these chemicals is, and it could be really important to your study. It's another way to pull information about chemicals into the Abstract Sifter. I'm going to take a pause here and come back with another example. In the presentation, I also talk about retrieving tox prints, which are chemical features that you can go out and retrieve and then sort chemicals by them, etc. I have several videos out on YouTube about using tox prints. There's 2 of them, I think, that I recently did. So I'm not going to cover that here. And there are many, many videos out here that cover the different aspects of document retrieval from PubMed. So I'm not going to do a lot of that. You can go look at those videos. I'm going to show you that on this version of the Abstract Sifter, which is version 9, it's not just a PubMed retrieval tool. And that's one of the why I've got a version version 9, is that you can do the same query on a number of different resources and get different results, and then you can eliminate the duplicates, if there are duplicates, among all the sources. There are separate videos, or there will be soon separate videos for all of those things. So I'm going to call it quits here for this presentation, and just hope that you will go ahead and look at some of these other videos to get the information you need. Thank you very much.